Hello guys, in this video I would like to explain about the differences between regression and correlation. Uh, Usually some people use these two concepts interchangeably, which is not the case. Actually, there are various differences between these two concepts. And in this video I would like to explain so that you can understand this better and then you can use any of these concepts according to the situation which you have in your research and data analysis. Uh, m- if you don't understand, then maybe you can confuse and you can use regression instead of correlation or correlation instead of regression. And at the end, you will be unable to explain the phenomena which you actually have. So after watching this video, you will be able to choose any of these methods according to the situation you have. So let's move to the content and see how we can differentiate between these two concepts. The first thing is purpose of regression and correlation. So this column, the left side column is for regression and the right side column is for correlation purpose. Regression estimates the relationship between a dependent variable and one or more independent variables. It is used to predict the value of the dependent variable based on the values of the independent variables. So there are two purposes actually. One is to estimate the relationship between the dependent variable and one or more independent variables. So there is a relationship, and we can see that how much and in which ways, I mean, negative, positive, or whatever, the dependent variable depend on the independent variables. And the ultimate objective is prediction of the dependent variable based on the values of independent variables. I will explain this when there is an equation in the next slide, so I will explain this again. So this is the purpose of the regression analysis. Correlation measures the strength and direction of the linear relationship between two variables. It answers the question, how strongly are these two variables related? So this quantify the relationship between two variables and give you a single value. So the magnitude of the correlation coefficient show the strength of the relationship, and the sign, negative or positive, show the direction of the relationships. So I mean that these two methods are used for different purposes. You should know this, that in which situation you can use any of these concepts. Direction of analysis regression involves a dependent variable, response variable, we can say response variable, dependent variable, and one or more independent variable. We also call predictors. It quantifies how the dependent variable change when independent variable change. So yeah, this is the actual thing, that we measure the relationship between the dependent and the one or more independent variables or predictors and see how the relationship change. I mean, how the dependent variable change when we do some changes in the independent variables. On the other hand, correlation does not differentiate between dependent and independent variable. It only measures how the variables move together. So there is no concept of independent and dependent variable in the correlation analysis. It just calculate the correlation coefficient and show how they're strongly correlated and in which direction they are moving. So this is another difference between these two concepts. Output. A regression provides an equation that models the relationship between variables. For simple linear regression, the equation is typically of the form y is equal to mx plus c. This is the same equation as you can write y is equal to beta x plus alpha, or y is equal to alpha instead of c plus beta instead of mx. So the equation will be y is equal to alpha plus beta x. The same thing, you can't change it. There is no, you don't need to worry about this. Where c is the intercept, y intercept, and m measure the amount of change in y as per unit change in x. This means that when you change x, this m show that how much change will occur in y. So you can see here it is explained. where y is the dependent variable, x is an independent variable, m is the slope indicating that the change in y for 1 unit change in x, and y c is the y intercept. So this is something like this, and I already said that I will explain the prediction. So you can predict y. When you estimate this equation, you have a value for the parameter m and c. When you provide any value for x, you can predict y. So you can predict y based on the value of the independent variable. However, you cannot do this in correlation analysis. Correlation produces a single statistic called the correlation coefficient, typically denoted as R, Pearson correlation for linear relationships. The value of R ranges from -1 to 1, where R is equal to 1 indicate a perfect positive linear relationship. R is equal to -1 indicate a perfect negative linear relationship, and 0 indicate no linear relationship. So correlation, on the other hand, give you a single value which range from -1 to 1, and you can see different repetitions. So if it is 1, this means perfect positive linear relationship, and if it is -1, perfect negative linear relationship, mean that the variable are moving in the opposite direction. But if R is equal to 1, this means the variable are moving in the same direction. Perfect relationship is there. And if 0 means that there is no associated relationship between the two variables. So the two concepts are quite different in this aspect as well. Interpretation. Regression provides more insight into the nature of the relationship, including prediction and the effect of size of the independent variable. Size of the independent variables on the dependent variable. It can be used for causal inference if the study allow. So interpretation, you can see that in the regression analysis, you just see the relationship between the two variables, and you can do prediction as well, and you can see that how much impacts are there on the dependent variable from the independent variable. So something interpretation for the regression, and it can be used for causal inference as well. On the other hand, correlation only indicates the degree of the association between variables. Yeah, this just gives you a single value, and you can see how much these variables are correlated and in which way, and positive or negative. It does not imply causation, meaning that a high correlation does not mean one variable causes the other variable to change. Yeah, there is no concept of this thing because there is no independent and dependent variable. So this is another difference between the two variables, the two concepts. Assumptions. A regression assumes a specific form of the relationship, e.g. linear polynomial, and it requires rational assumptions such as normality of the residuals, homoscedasticity, and independence of error. So regression analysis, maybe you assume the linear relationship or polynomial relationship or any other type of relationship. However, this requires further assumption that the normality of the residual, homoscedasticity, and independence of the error term. There is no serial correlation or autocorrelation. I will have a separate video on the homoscedasticity because this is an important concept, and we will see that what is meant by homoscedasticity, and if there is homoscedasticity, how we can tackle this problem in the regression analysis. I will have a separate video in a few days, a couple of days. On the other hand, correlation assumes the relationship between the variable is linear and the data, and that the data are homoscedastic, equal variance across the ranges of the variables. So this means that the relationship is linear. This is the assumption, and the data is homoscedastic, meaning that for different ranges of the data, the variance is same. So this is another difference between the two concepts. Visualization. Both concepts can be visualized by using scatter diagram. However, the difference is we have a regression line in the regression that show the relationship between the two variables can be represented by an estimated by a line, regression line, which is represent the estimated relationship between the variables. So we can draw a scatter plot and then we plot the regression line, which is the relationship between the two variables. The correlation often visualized using a scatter plot with the correlation coefficient. In the correlation coefficient, we also draw a scatter plot, but we provide a single value of the correlation and the strength of the relationships. This is also quite different in this aspect, these two concepts. Symmetry. I will start from correlation. Correlation coefficient is symmetric, i.e., covariance between x and y is equal to covariance between x and y. So if you want to calculate correlation between x and y and x both will be the same, so this means that the correlation coefficient is symmetric. Regression coefficient may not have the property of symmetry. Maybe the regression between x and y and x is not the same because one is dependent variable and the other is dependent variable. So you can check this for dependent data set, but this may not be symmetric. However, for sure, correlation coefficient is symmetric. So this is another difference between the two concepts. Prediction. Regression is useful for prediction purpose, and of course, the ultimate objective of the regression is predictions. You need to estimate the regression model, the relationship between the two variables, and then predict dependent variable based on the values of the independent variable. Correlation cannot be used for prediction purpose because you don't have this relationship. So if you don't have this relationship, you cannot use this correlation for prediction purposes. So this is another obvious difference between the two concepts. So there are multiple differences between the two concepts, and I hope you understood what are the differences between the concepts. So if you understood the differences between the two concepts, then I'm sure you can choose any of these methods according to the situation you have for your data analysis and research. So thank you very much for today, and see you in the next video. Ciao.